the bone, using Behave and Selenium to test drive web applications. I will be saying Selenium or Selenium all the way through. I pronounce things ambiguously. I don't know what the real one is. I apologize. My apologies in advance. I am recording this talk. I'm planning on putting it on YouTube later. If you don't want your voice to be on video, come find a question for me afterwards. I'll be here in person or hit me up on Twitter. My name is Pat Bufor. I'm a software engineer at Adtran, Huntsville, Alabama. You may know me from previous talks like yesterday. Lightning Talk, how to fight your screen windowing manager in front of hundreds of people and lose. It was so successful, I encored it 5 minutes later. So the demons, I had some demons haunting my laptop, and so I took it to a local priest, said, let's go exercise it. I asked him to exercise a little too many. All my programs that ended in D stopped. Linux puns, terrible puns to start off. I'm doing great. Anyway. We're going to start with a story. I like stories. Or an example, a thought experiment. Let's say you go to work and you work at this beautiful building, rendered in painstaking detail, and it's a normal day of work for you. Yeah? You're trying to figure out what you want to do. And you hear a knock. You turn around, you open up your office door, and you hear your boss. He goes, hey, have you heard about URL shorteners? And you go, URL shorteners? And he's like, yeah, it's a big thing these days, you know, maybe not, but let's see. You know, like the Google URL shortener, you got Bitly, you got TinyURL. The idea is you're going to take a big long URL and condense it down to an itty bitty URL. Your boss tells you, hey, I want to tweet things out. I need short little URLs. You know, tweeting's a big thing. It goes all the way to the top these days. So it starts to give you some requirements. It says, for this URL shortener I want you to build, I want it when a user enters in a URL, they are provided a shortened URL. Okay? When a user navigates to that shortened URL, they are redirected to the original URL. So this is a way for me to create a mapping between the two. That should be as fast as possible. They also want to see how many people have been redirected through that URL. Those are the first 3 requirements he gives you. You're like, great, I got this. And then he hands you a design document with 500 more. We've been there. We're only going to focus on those first 3, though. So how are we going to attack this? How do we start coding this? Well, let's try TDD first. You know, who here has heard about TDD, test-driven development? A good portion of you. Idea is you start with a failing test. You write just enough code to complete that test, make it pass. Then you refactor mercilessly. So I have Patly, my own little URL shortener. And if I were to say, let's put in a link, let me jack that up. So if I say give me python.org, it gives me a new link. And if I go say, open this up in a new tab and say, let's say, where does this expect me to take me to? I made a mistake. What went wrong? Well, it turns out when you look at the code, it looks like some junior developer wrote it. In fact, my 1-year-old son wrote this. It wasn't me, I promise. So it's hard coding things. When we create a link, we're always going to return the same shortened link. When I go redirect to a page, it always redirects to google.com. So we're actually going to go implement this and see how it goes. I'll implement a little bit, give you an idea, and then I'm just going to fast forward a bit. So, cannot see my entire page. Actually, I'm going to create a file, touch URL shortener.py. I tested this earlier. I'm missing like the 200 pixels on the left screen. Bear with me. URL.shortener.py, and let's make that. All right, so I'm going to start off with writing a failing unit test. I want to create a URL shortener. So I will grab my unit test, import, I'll create a test URL shortener, unit test case. And my first test is I want to make sure I can shorten a URL. All right. Normally I like to start off with the assert, kind of get me in the mind of what am I trying to test. So I want to assert that some URL or let's say some shortened URL equals, I'm actually going to say a shortened index. Index equals 1. and I need to figure out where I'm going to get that from, so that's shortened index. I like working backwards on a unit test. Index equals some URL shortener, got shortened, and I'm just going to paste in python.org. Python.org, all right. And then I need to actually create a URL shortener. URL shortener, all right. So if I were to run this test, I'd expect it to fail. I don't have a URL shortener written yet. So I'll load up my unit test, URL shortener. I should see one failed test. I always like seeing that failed test to make sure that I actually have my unit test hooked up right. Now if I go write this unit test, write the class, let's say a URL shortener, object, dash, shorten. I'm just going to return 1 because I just need enough code to make my unit test pass. So if I try that again, still messing up.
Yep, the variable spelled different.
I did that like 3 times while practicing too. I am consistent. Shorten takes. Helps if I give the URL. This is why I write unit tests. All right, 1 test passed. It's hard-coded. I can keep evolving this and evolving this. I'm not going to bore you with what TDD is. What I'm actually going to do is I'm going to remove that file. And I'm going to do some git magic. Check out unit testing. All right. I need to get the file to URL shortener. And look at that, in the magic of minutes, I just wrote that all out. You guys must have blanked. I swear I just did that. And I wrote this completely TDD. I said, all right, test retrieve shortened URL. I have 7 tests here. I'm checking getting stats. I'm checking retrieving things. And if I run my tests, nope. Run my tests, ran 7 tests in 0 seconds. Awesome. I broke space and time. I really wish it gave you, like, ran it in some minuscule amount of seconds, but oh well. And so you can look at this code, but it's working. My unit test passed. I am done, right? Let's go look at my code. So let's refresh this. Let's reboot my web server so that I pick up those changes. Oh, lovely. Bear with the technical difficulty. Apparently, it did not release well. Where's the number? All right, take 2. There we go. All right, so if I refresh this page, if I type in give me HTTPS python.org, give me a short link. Copy that off. And it worked. URL shortener in the magic of seconds. And all my unit tests pass. That's great. I'm done. I'm going to hand it off to my customer, and it's going to be great. But my customer gets it, and he takes a look and goes, this isn't what I want. Let's look at those requirements again. When a user enters a URL, they're provided a shortened URL. Look like I got that. When a user navigates to a shortened URL, they are redirected to the original URL. This should be as fast as possible. Yeah, I blinked and it was there, so it looks like I got that. And there's a way to see how many people have been redirected through this URL. I go back and refresh. I get this like table that tells me how many times it's redirected. I wrote that code. I unit tested. This is perfect. The customer wants the path URL. What went wrong? I put in the Python call. My unit test passed. This should have worked. Am I out of touch with the customer? Am I getting this wrong? No, it must be TDD that's wrong in this case. I mean, I wrote my unit test, and I'm told that when I write unit tests, my code will work. And my customer is coming back and says, no, you still have a bug. That's wrong. TDD is actually really, really great. The problem is we're trying to use it to answer the wrong question. Tests are meant to answer a question. They can't prove there aren't any bugs. They can't prove the absence of bugs. We wish they do. Our bosses wish they did. But the truth of the matter is bug space is infinite. Instead, we use tests to answer a question. So here are some questions that I like that different classes of tests will give. Do I have confidence that I can ship my code? Does my code do what I want it to do? How does my code work with 10,000 users? Can my code run for weeks on end? Does my code do what my customer wants? These are questions I might ask and use tests to answer this for me. Does the code do what I want it to do, what me as a developer do what it wants to do? That's where unit testing comes in. But there's other questions to be asked, like does my code do what the customer wants? This is a key distinction between this. Today we're going to be talking about behavior-driven development, or the tests that answer this question. How do I make sure I'm giving code what my customer wants, not just what I mean it to do? This is acceptance testing. You can do acceptance testing in Python. I could even use the same unit test framework, or PyTest, or Nose, or any of the various test frameworks out there, and write scripts that hit my website and say, okay, I'm hitting a REST API and it's giving me what I want. And that gives me this nice little safety net. Like unit tests are a safety net for the developer, acceptance tests are a safety net for the customer, making sure that we're doing things right. But there's some problems if you write your acceptance tests in straight up Python. I still have to figure out exactly what the customer wants. If I'm just being given a requirements document, I still have to parse that weird little English that they wrote and make sure that I'm being as precise as possible in my code. The customer is going to change their mind. How do you communicate that really well? If they change their requirements, how are you going to know that your tests need to change? How do you get that communication pathway? And you have to trace back to requirements. If I have a test and the test changes, can I trace back to a requirement to know that I am actually doing the right change? Conversely, if the requirement changes, can I say, okay, here are the tests that need to change? I don't really have that if I'm just writing some acceptance tests straight in Python. I have to keep things in sync. Requirements, tests, requirements, tests. This brings us to the idea of executable specifications. Executable specifications. I want my requirements to be executable, meaning I say run on my requirements and it tests out my stuff. I want to have my test written as close to plain English. I want my requirements, my test to be written as close to plain English requirements as possible. I want to run these tests often to make sure I'm always giving the customer what I want. By now, either you know where I'm going or you think I'm smoking something. It's like, that can't be done. So I'm going to introduce you to the Gherkin language. Who here is familiar with Gherkin? All right, good portion of you. So you know where I'm going with this. This is an example of the Gherkin language. It is a test case specification. I start off with a feature. Our service makes short URLs, blah, blah, blah. This is like an overview. This is a test suite, or in a sense. I have a scenario, shortening a URL. This is like a test case in a test suite, or like a test plan. And then you're going to hear me talk about given, when, then. Given some precondition. I have a URL at http www.python.org. When we shorten it through a service, when we act upon what we want to test, then we should receive a shortened URL. Given, when, then. Given a precondition, when I act, then I expect this postcondition. In unit tests, you even have this as well. Some people call it arrange, act, assert. So let's go look at some features. Let's go see what they actually look like. Again, with the magic of time travel, I'm going to code it all up in a few seconds. Sure. All right. So, I have this test folder now, and I have a list of features. See if they all fit. So, it's almost the same thing that I just wrote, but shortening a URL. I have a scenario for that. Scenario, retrieving a URL is fast. And given we have shortened the URL, python.org, when we navigate to that short URL, then we arrive at python.org as fast as possible. Also, I have a scenario for getting stacks. This is what a Gherkin file looks like. Okay, nothing too special there. Kind of just looks like a test document at this moment. I'm not really solving any of my problems. There's a Python library called Behave. If you're familiar with Cucumber, RSpec, it's the same sort of idea. Behave lets you hook up Python code to those Gherkin statements so that you can back up every one of those statements into executable code. Those Gherkin features become your executable specifications. I can run that file, and there's Python code backing it all up. And it tests it, which is really nice. My customers, my customer proxies, my product managers can read this file and say if there's anything wrong with it, or they can make sure that these requirements are correct. If I had to go here, if I had to give my PM or my customer, like, hey, here's my Python file, this does your requirements, they're gonna, no, and hand it right back. This lets you drive the requirements conversation up front with the customer. You're starting to get very precise, because we all know computer programming, software engineering, slinging code, the toughest part is getting the ideas from your head into English, into code. It's that getting to the code that's really tough. You think you know what your customer wants, but as soon as you show it to him, he'll have other ideas for that. So Gherkin, I'm going to show you how to write up those steps, the implementation behind those Gherkin features. So if I type, I have already pip installed this with behave, it's Python library. If I point this at my features folder, it's going to tell me a whole lot of text that, frankly, I don't care about. But it's saying, hey, here's the scenarios I'm trying to run, and these things aren't implemented yet. The nice thing is, all this text I skipped over, that you can paste into your file, and it's giving you the step definition. So let's do that. So, for every step that I have in this scenario, it auto-generated one for me and say, you're missing these. Just go put these in your file and we'll get you on to the next step. So I'm going to copy those off. I already have a steps file. So behave operates on convention. You can configure it to do different things. It expects a folder named features, and it expects a steps folder inside of that. The features are your test cases, that Gherkin syntax, and then your steps can be any Python code. So I have a file called URL shortening steps.py. It is empty. I'm just going to paste all of that in there. You see that? It gets a little long, but it's the steps that you saw in the actual Gherkin file. So if I come back here and I run behave again, it gets a little further. It actually is throwing errors saying you have not implemented this yet. So that's a good start. Let's go back and look at the code. Unfortunately, they can't just auto-generate what you want it to. Like, hey, just give me tests that already do what I want it to. Once that happens, I'm out of the job. So any of these sort of things, you're going to see a step impl. There's a Python decorator before everyone saying whether it's a given, when, or then. You can actually use givens as whens or whens as thens. This is just for convenience, for readability. So, and you'll notice there's a context passed into every single one of these functions. The context is shared all the way across all these. So you can save variables in one step through your context and then reference them later on. So say I'm given a URL, and I don't want to hard code this URL. I can actually just parameterize this, which is nice. You can parameterize it with their own custom capture language. You can parameterize it with regular expressions. Behave has a lot of cool features out of the box. And I'm just going to save this off for later. URL equals block, or URL. And forget not implemented error. When I short it through my service, I don't know how to test this yet. We'll get to it. But I'm just going to say, I'm going to save off a variable, shorten URL equals, I don't know yet. Figure this out later. And when we should receive a shortened URL. So, what you do in behave is use assert statements, just like you would in PyTest. You're asserting that a certain condition is true or false. So I want to make sure that my context.shortened URL starts with https path.ly 88. It's the best I can do right now. Yes. So that's making sure that I'm putting in some sort of test against that requirement. If I go run behave again, I still have a failure, which we expect. I'm going to scroll back up. I actually got 2/3 of the way through my Gherkin specification. If you can see, given a URL, https www.python.org, if that's green, it passed. No asserts failed in that, no exceptions were thrown. It throws an exception because I'm comparing an empty string versus what should be starting with path. But that's the basic idea through all this. How am I going to start getting this filled out? So, how are we going to implement these steps to be something meaningful? I think I've showed you can reference things from across different steps, you can parameterize them. How do we implement these to be something meaningful? So a quick HTTP little background for people. When your computer makes a request to a web server, for let's say for Patley, and unfortunately you guys can't do that because I'm hosting Patley on my local computer. It will take you nowhere. Too cheap to pay for DNS. What will happen is it will send an HTTP request to the server that's hosting that web page. That server will say, okay, I know what to do with this. I have an HTTP server here. I'm going to go find the resource you're looking for and return it to you, along with all the JavaScript it might be needing, all the CSS, the HTML files, and so on. There's some pretty great HTTP libraries already in Python. There's URLlib, that's built in, and URLlib too. You can use that to start getting HTTP resources. There's the ever popular requests library. This is, I think, the most downloaded package on PyPI. It's awesome. I can't say enough good things about it. But just because it's awesome, it doesn't fit the bill for what I need. These are HTTP libraries, not JavaScript libraries. They're not CSS libraries. All they're doing is just saying, give me this resource. Even if they did do JavaScript, even if they executed JavaScript to see what the page looked like, and I came across a few that do, does it do it the same way as the browser does? If you get back to why I'm advocating behavior-driven development, is to make sure that we're giving the customer what they want. The customer is going to be going through Chrome, or Firefox, or Safari, or mobile, or Internet Explorer, or Edge. And anyone who's done front-end work knows the pain it is when you have this function only exists in Internet Explorer 10, and this function doesn't exist in Internet Explorer 11. Chrome and Mozilla differ, and it's a headache. If you're just doing these little one way of doing it, like skirting the web browser, you're missing out on how the customer is actually testing these things. You're not able to test clicks, mouse hovers, all these other front-end things, CSS animations, things the user is going to see. You're not actually testing if you're just skipping the web browser completely. I use requests, URLlib, for things like integration tests, but for acceptance tests, when I want to give what the customer cares about, I can't do that. It's your responsibility to deliver a solution, not just a piece of code. You might think I'm a back-end developer or he's a front-end developer, but really you're all working together to satisfy the customer's needs. That means it's your responsibility to take care of that as well. You got to work with the whole team to say, how are we testing this like a customer uses it? So let's talk about Selenium. Selenium lets you control a web browser through Python. It is awesome. For those of you who don't do too much HTML, you can kind of see whenever you receive an HTTP request, get an HTML document, you parse it, it gives you this tree format. You have an HTML node at the top that has a head and a body. That body might have an input field, it might have some text, might have a table. That table has rows, there's cells in those table rows, and inside those cells is actual text. With Selenium, I can do things like browser.findElementById input, and it will search this tree for the first node that has the ID input. You can also nest things. I can say, hey, find me the element with the ID stats, and that's this table I've highlighted. I can save that off in a variable, and from there, I can say, table, find me the elements by a tag name, the TR, the table row, and give me the fourth one. From there, I can get the cell. Find me the element by the tag name TD, the first one. And from there, I can get the text. I can do this all through the browser. As a matter of fact, let's go do that. Let's go see how it looks. So, let's open up Python, legacy Python. All right, from Selenium, import WebDriver. If I say browser equals WebDriver.Chrome, and I have a special, you have to download a special driver for this, but you can do Firefox, Internet Explorer, you can even do a headless browser, one that doesn't even have a window. Really helpful for automation on a headless server. So, a Chrome window popped up, awesome. I can say browser.get https google.com. And I have transparency so you can actually see it went to Google in the background. I want to type something into here. whenever you're interacting with a page, inspect element, dev tools, Firefox debugging tools are your friend. So I'm going to inspect this input box, and it has a class name of GSFI. These change randomly, so I can't rely on it, which is why I have to do it every time. If I were to say input equals browser.find element by class name, GSFI. Hooray, found it. It'll throw an exception if it doesn't find it. Input, send keys. Python is awesome. I did not say legacy Python. Python is awesome. All right, and if you actually go back to my webpage, it typed that into the input field for me. I can control the web browser through Selenium. Awesome. Browser.close, so I don't leave things out. Good. All right. You can find elements a whole bunch of ways. Name, class name. You can find things by link text or partial link text. If you know CSS, CSS selector. We had a lightning talk yesterday on XPath. Don't see them in here. You can find things by XPath if you're familiar with that. And once you have those elements, you can interact a lot of ways. You can click on them. You can modify cookies. You can move your mouse around. You can screenshot. And here's the best thing. You can execute arbitrary JavaScript. You give a developer unlimited access to a programming language, he has the world in his hands at that point. So let's go look at the tests again. Let's go see. I'm going to start going through a few of those to say how would we actually test this out. So, given a URL, I'm going to keep this how it is. I'm going to try to say, how do I figure out what this shortened URL is? Well, I know I'm going to need to first shorten the URL. I can see that my when steps is when we shorten it through our service. I want to make sure that the code I write matches up with that step that I'm given. It's like a law of least surprises. This is the customer trusting you that you're going to write the test that actually implements the features that they're specifying. So I want to first shorten a URL. And I have that URL saved up here because I know this given will be run first, at least in this feature. So how are we going to do that? Let's go take a look. I have an input field. I'm going to go inspect it. Its ID is input. Awesome. I'm going to inspect this button. Its ID is get-short-link. All right. See if I can remember that. I only wrote, no wait, my 1-year-old wrote this code. I didn't. All right. So, first off, I'm going to say, I need a browser. So let's import Selenium just like I did from Selenium, import WebDriver. Browser equals WebDriver.Chrome. And you can parameterize different behavior runs so that you could do one run for Chrome, one run for Firefox, one run for Internet Explorer. Really, really handy when you need to test a multitude of things. So I have a browser. I'm going to find element by ID input, and I'm going to send the keys. So I'm sending keystrokes to the browser. That's my context.url. Let's see here. Then I need to click that button. So browser.find element by ID get-short-link .click, because I can click on things. And then I have to figure out what this shortened URL is going to be. So let's go back to our webpage. Well, if I'm just blah, 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 I have no input validation, bad path. I have this link, I'm actually going to inspect it. It has an ID of return link. Now, if you have control over the web page, and you're not finding an easy way to query the elements on the page, you might want to talk to your front-end team and say, hey, can you add an ID on things, or you have a name on things. Otherwise, you might get these big, long, ugly XPath statements, and that's not fun to work with when they get super, super long. But since my son is awesome, he put an input ID on there, I'm happy. So ID equals return link. I am going to browser.find element by ID return-link.text. So I am keeping the shortened URL, and it should find that. I'm going to go run the test again. So exit out of Python, hey, test/features. Cross my fingers. You'll actually see a page fly up there real quick, and I got something wrong. Oh, I know what I got wrong. my apologies. Helps if I navigate to the page first. Browser.get http pat.read 80/. Opens up a page, you actually see it go through. I just controlled that from a test. And it still failed because I did something else wrong. I'm not going to waste your time. Could not find IDs.
Did you mean to go to the root or the slash one page?
What was that?
Did you mean to go to the root or the slash one page?
They both redirected the same. I'm not actually redirecting, it should just be giving me something back out. Anyway, through the magic of Git, this is why I have all my code written in Git, because I do not do well with live coding. So Git reset, hard head, all right. Git checkout. Okay, so I completely cheated. Let's go find our steps. Oh, I'm there. My bad. So what I did is I'm actually just going to run this first and show you what it looks like. Then we'll go into the code and see what I'm actually doing behind the scenes. So if I run behave, enter off the keyboard, you see a web browser going up and down on my screen. I'm redirecting, I'm hitting different URLs. I am waiting for Chrome to load. Yeah, okay. I'm on to bet my web server. Oh, no, it went. Hooray. See it redirected to Python twice, it's going to redirect to Google 3 times. And I get a nice little page of all the things that went on. So because I knew I had that bug where I'm putting in the wrong URL in my stats table, I'm expecting this to fail. But my others are passed. So let's go look at the code. So I'm going to call attention to a special file that I created, environment.py. Again, behave does things by convention. It gives you a way to kind of hook into things with before scenario and after scenario. What do you want to run before scenario? What do you want to run after scenario? I'm spinning up a new web browser every single time just to kind of isolate some things. I am not spinning up my server every time, so I'm making a tough little decision here. If you want to spin up your web server every time to isolate the web server between test runs, it's going to slow things down. Your alternative is you only run these tests once when the web server comes up. You have to balance out time and complexity on that, and that's going to be a decision you guys are going to have to make. But before every scenario, I am creating my web browser, and I've actually created an object, Patley homepage driver. This is known as a page object pattern. Anytime I'm dealing with a web page, and this is a common pattern, this is not just me. Maybe it is, I'm delusional, I don't know. You wrap your web page in an object so that whenever the UI changes in one place, rather than going across the hundreds of step implementations that you may have written. So like when I get a stats table, I'm delegating to this object. That way, if someone says, oh, I'm going to change the table name to be randomly generated, I can change that one place inside my object. We'll go take a look at it, and I'm good. So, Patley homepage driver, let's take a look at it. I have same sort of code you saw. I have a shortened method. I'm using the browser to send keys, find the element, and then return the text. When I go to a page, I'm making the, how do I go to like python.org, or how do I go to my home page? When I get stats, I am finding the element by ID, that table, and then I'm going row by row, building up a dictionary of all the stats that I'm looking for. And I also have a quick method, checking if I'm at a current page. So now when I look at my steps, they're actually very straightforward. Again, law of least surprise. When I've shortened a URL, I'm keeping track of a map. So I save off the URL. When I shorten a URL, I'm calling the shorten function. And then I save that off in a mapping between the URL and the shortened URL, just for later, so that I know that when I'm checking things, I have that information saved. If I'm navigating to a page a certain number of times, again, very straightforward. I'm navigating to that shortened URL num times, and you'll see this :D. Behave lets you actually do some optional type annotations in there, so that what happens is, like, if that D is a integer. If If I put in a string, you'd actually get a behavior up front saying, I don't know what you meant by this. I use that, so I back up. Num times, if I don't put that in there, is a string, and I'd have to convert it to int into my test. By putting that type annotation up there, I know it's an int by the time it hits my code, or a number. I don't have to worry about it being a string and doing the conversion myself. So a little shortcut. But again, straightforward. For a number of times, I'm going to a page and going back to the home page, calling shorten, navigating to URLs. The idea is I'm making this so simple that if someone were to code review it, they know like, okay, yes, you're doing exactly what I expect. And this gives the customer a little bit more confidence too, because they can write this vocabulary, and over time they're going to start mixing and matching vocabulary in ways that you weren't expecting. It lets you really make sure that, okay, when they say this, I'm doing exactly what they say. When I say we navigate to that shortened URL, the code is browser go to page that shortened URL. Makes sense. A quick note, one of the requirements said we arrive at a URL as fast as possible. That's a bad requirement. I mean, what does that mean? Do they mean within a second? Within 100 milliseconds where human response time will pretty much say it's instantaneous? Or do they really mean fast as possible? If they mean fast as possible, give me $1 billion, I'll solve quantum computing, the bill will be fantastic. So when you start trying to implement these steps, you're going to find ambiguities in the requirements. Don't assume what the customer wants. Behavior-driven development is all about doing this first and having those conversations with the customer to say, what do you really want? They're still going to change their mind here and there, but when they do, they go update that feature specification. Your test might still, you might even have to change that. They're still within the same vocabulary, but you're working with them. Your customers are not your adversary. If they are, maybe you're in a gladiator cage match. I don't know. But I like working with my customers rather than against them. All of this is still the same thing. You saw my starts with Patley 8080, making sure that shortened URL has been visited a number of times. And it's also fun just to be like, if you ever need to convince someone, hey, we should be using like Selenium, just start writing some quick things and be like, oh, hold on a second, I don't need to do manual testing. I can just walk away and let my web browser do its thing. It's kind of magical in a way. That's what I love about this. And like I said, if you're doing this in automation, like on a CI server, you can do this in a headless browser, but you do lose some of the benefits of testing out the browsers the customer will use. All right. This is your safety net. This is what makes sure that when customers change their mind, when they write requirements, you are implementing what they want, not what you think it should be doing. There's a lot of cool features of Behave. I'm just going to pick a few that I use. Scenario outlines, the ability to parameterize the Gherkin feature themselves. So you can say, given a URL, blah, and later on in the Gherkin syntax, have an outline saying, here's all the URLs I want to try in tabular format. Makes it really easy for people to add new test cases on the fly. That environment file is super powerful. You can do things before features, before scenarios, before steps, or after any of those. And there's the regex matching as well. So this is the tough part of the talk. No programming tool is a silver bullet, or a golden hammer, or some awesome golden hammer that shoots silver bullets. There's always going to be something wrong with the tool you're using. There's some cases where it doesn't match up. I would not use behavior-driven development for my unit testing, for example. Selenium, or rather the web browser, is actually quite slow. When I call a function, blazing fast. But when I'm using Selenium, I have to spin up a browser, I have to go make some call across processor boundaries, it has to go execute JavaScript or something inside the browser. It's slow. And there's a reason for this. This is the famous test triangle. The idea is you have so many of your unit tests that you're catching a lot of the negative cases, the unhappy paths. Your integration tests are catching a little more. But as you go up that triangle, you're writing less and less of these. Acceptance tests should just be what the customer cares about. If the customer cares about the negative cases, okay, go ahead, write a test. But your unit tests are your first line of defense. I don't use acceptance testing as my first line of defense. I once did, and I regret it, because we had this web app at work, and there was a 35-minute acceptance test. It was awesome because I said, oh, I can run this, and I can just deploy it, and I'm fine. But it also meant that every time I wanted to deploy, it was 35 minutes of waiting. Most of that functionality could have been checked by a unit test and run in under a second. And that test week should have been a few minutes of just testing out what my customer wanted, not making sure, oh, what happens when I get a 404? What happens if I get a 500 server error, and trying to mock up and build all this test infrastructure for that. And acceptance tests can be unwieldy if you have a lot of them. As much as I love them, if you have a whole bunch of them, it's going to be really tough to start to manage all of them. Because there's extra work on this, don't get me wrong. It is not for free that you are writing Gherkin files and you're backing them up with step implementations and that you're maintaining them. Most people forget test maintenance. If nobody reads these, you lose some value. These are written in close to plain English because they're meant to be read. If nobody's reading them, you lose some value. You still have some value because the act of writing them first helps guide you, the whole behavior-driven idea. You start with a customer vision out in the mindset, but if nobody's reading them, looking at them, maintaining them, you lose them. And like I said, the UI is typically one of the more fragile pieces. One of the reasons is, the first thing the customer sees is your UI, which means this is going to be the first thing they'll nitpick, the first thing they'll find bugs with, the first thing they'll have an issue with. Oh, that green is a little too light for my purposes. Or you might be testing things that are a little unstable, and the front end team is randomizing inputs or changing IDs for your fields. Use that page object pattern, wrap them in an object so that when your UI does change, you change it in one place. But with all this being said, there's still quite a bit of value to be had. Driving the conversation with your customers is critical. So, don't let your requirements go out of date. Don't keep two things that have to be synced. Use a single source of truth. Keep talking with your customers. It's critical. And you want to build that safety net of your acceptance tests. So when you add BDD, Gherkin, Behave, Python, Selenium, you're giving your customers what they really want. That's it for me. All these slides are up on, or all this code is up at my GitHub. It's a separate branch for the steps that I went. If you did blink, I did not just magically code things up. Follow me on Twitter. Hit me up with questions, complaints, criticisms, whatever. I don't care. If you criticize me, I'll only cry for like 30 minutes. Now, in all seriousness, I welcome feedback. I'll be around for a little bit longer today. For any questions in the 2 minutes we have? Yes.
Is it pretty easy to plug into Jenkins or anything?
Yes, I've actually plugged it into Jenkins. The headless browser is the important thing, unless you don't mind it spinning. Like if it has an X Windows session, then you can spin up Chrome, Firefox, all you want.
And have you figured out a way to like generate a nice report or something after you run that you could like take to your customer?
Yeah.
And say, hey, it passed like a unit.
Yes.
Test, you know?
Yes. There's actually a JUnit output specifier. It gives you the XML format that like JUnit also has, and if you use the JUnit plugin in Jenkins, it will actually build an HTML page for you. So we use that. And it's nice because it gives you a feature and by scenario breakdown. Yes.
Do you know of any projects that have a pretty good comprehensive BDD test suite that aren't either tutorial toy calculator examples or BDD frameworks themselves?
Unfortunately, I'm an open source slouch, and all the stuff I do is internal to my work. BDD can be used for more than just web pages. I wanted to hit some of the people who do Django or Flask development here. You can use BDD for anything. I would love to see more things like Python libraries have. Here are the features I support, so I don't have to go through documentation that can be out of date or source code and spend weeks trying to understand that. I don't have any good examples. If I had a lot of examples, I wouldn't give this talk. Yes, sir.
Is there any resources that you found for taking a huge requirement, or, okay, we want to do a project that does blah, and then breaking that down so you end up with features that are testable?
No, I do not know of a really good resource. It's just some elbow grease, I'm gonna suggest that conversation of breaking that down is the most valuable piece. Writing the test is not the most valuable. It's that conversation with the customer of what do you really want. It's a tool to drive that. I don't know of a good way to say, given this big document, how do I want to do it? Are you familiar with the strangler pattern at all?
What?
The strangler pattern. The idea is when you have an old way of doing things and a new way of doing things, convert just one or two pieces over to the new way of things and do all new work in that new way. And over time, the new way will strangle the old ways. You can live in both worlds for a little while, but it gives you an incremental migration path. No company is going to say, yes, please take 1 year to do nothing but convert requirements to Python code. So I use the incremental way and see if your management and customers see value from it. And if they don't, you're probably going to have an uphill battle that you're going to either say, yes, there's still enough value that I need to fight for this, or they're right, maybe we aren't getting enough value from this. Nothing's a silver bullet, so I don't have a great answer for you.
Pretty new to BDD, but is it common where like the example you gave, you had input and output that matches something close to what you unit test to have something like that in code bases that you've worked on? Like,
I've seen that. It all depends on the requirements. I chose more closer to the trivial example just to explain, but there's also an idea of a customer journey where you're saying, let's take like an Amazon. What you might say, given a customer who is logged in, when that customer navigates to Star Wars Rogue One DVD, and they buy it, and they enter in their credit card, and then they cancel their card, then I expect nothing to be in their cart and no purchases were made. So you can capture more of a customer journey. This granularity of how narrow or how broad you go is going to matter to who's writing these requirements. And again, or who you're collaborating with. It might be you writing that Gherkin file, but you should be collaborating with your customers, and you build that vocabulary together. It doesn't just have to be input, do something, output. I could have tested that with a unit test, but again, I did that with my stats table, and I was still wrong.
well, I was more curious about sharing code between unit tests and
Oh, absolutely. You can absolutely do that. Build common libraries that can interact with some of the things. Also, I don't put asserts in any of my page object drivers because I only want my tests to be capable of certain things. I put booleans, like a function, are you at this page, rather than assert that you're at this page inside my helper classes. That way I can use them outside of the test environment. All right, I'm out of time. Thank you, everyone. You could have went to Genetic Out.